This third lecture is looking at the nature of the clastic sedimentary rocks. Remember that clasts were those broken bits of physically weathered material that came from pre-existing rocks. Well, so then it makes sense that clastic sedimentary rocks are rocks made of those clasts. We describe them by what we call their textures. And then another quick note here is that if you're looking in your book, he doesn't call them clastic sedimentary rocks. He actually calls them detrital sedimentary rocks. Same thing, same thing. So let's look. So first of all, we are talking about the clasts themselves, not the overall rock. So texture in this sense isn't the feel of something. And it's not like igneous textures either, where you're talking about the size of the crystals. You see, here it is the size and the shapes of the pieces of the rock. So now look at both of these slides. They are different pictures of two different sedimentary clastic rocks. In the upper one, you see a ruler up there, and each one of the black and white segments on it is 1 centimeter long, so the whole, so 1 black plus 1 white centimeter or chunk equals about, or 10 centimeters. It's about an inch, So 2.54 centimeters equals an inch. Okay, look at the clasts in here, the chunks, the pieces. This one here is rather large. It is rounded. Looks like a baked potato. Look at the edges of most of these things. They have rounded surfaces. There are some sharp points on them, but mostly rounded. If you're looking at a sedimentary rock and the clasts are larger than 2 millimeters, that's small, and they are rounded, then we call that rock type a conglomerate. Contrast that to the picture on the bottom, same scale but enlarged here, and here you can see the little individual white tick marks for each of the millimeters in the white block, but every one of the little white segments you see there is one of the clasts. And notice here they're all jagged, angular, pointy. It looks almost like broken, like you broke a window. It's broken glass pieces. They are angular, and so we call them breccia. Two terms, conglomerate, breccia, if you have gravels. Now, if you have something smaller than gravel, anything between 2 millimeters and 1/16 of a millimeter, geologists call sand. Yes, we actually measure things that small, and we define sand specifically. You're looking at the picture here, which is a microscopic photograph of a bunch of sand. Notice these are all little round things, but they're too small to be called a conglomerate. So sand, we are just going to call sandstone. That's simple. Although if you look at the pictures below here, we do have a bunch of odd terms that can also describe sandstones. Graywackies, arkoses, it goes on and on. Geologists like terms, but I'm going to strip a lot of this away so you don't have to know them all. Just the pictures here, again, look at, there's different colors, sort of different general sizes, but all of these are sandstones. So sandstone can be pink, white, it can be very coarse-grained, it can be very fine-grained. As long as it's within that 1/16 of a millimeter to 2 millimeter size, boom, sandstone. What about smaller than that? If the world of your clasts is smaller than 1/16 of a millimeter, we just call that mud. So when you're looking at mud in a puddle or a mud in a stream, you are looking at a bunch of clasts, but they're so small, 1/16 of a millimeter, you can't really see them as individual particles. You see it as just this sort of pasty mess that we call mud. Mud is going to lithify and turn into mudstone. And if you'll hear me talk about this here sometimes, if it happens to be layered, has sort of very fine layers in it, we'll call it a shale. So gravels, sands, muds become conglomerates or breccias, or sandstones or mudstones. Now, when we look at the class, we describe a few other things. We talk about how rounded they are, and we describe it as a continuum. There's a spectrum from poorly rounded to well-rounded. Poor rounded specimens are said to be immature, well-rounded mature. I choose this picture just to show you on purpose. It's not the shape of the outer rock. Notice these rocks are both perfect spheres, perfect balls. That's not what we're talking about. We're talking about the clasts within. And so rock A here has well-rounded clasts. They're all rounded. Rock B has poorly rounded clasts. Rock A is said to be mature. Rock B is said to be immature. If you think about it, people grow up from immature kids to mature adults, hopefully. So that should give you an idea that these immature rocks, like B, ultimately over time become mature rocks like A. And how this does this is as these clasts travel. If they travel a long way, 1,000 miles, 2,000 miles, longer, they go from jagged, angular pieces to smooth pieces, just like those rock tumblers in that old kid toy that a lot of you had. Just some examples. The upper left here, A, B, and C. A is angular, C is rounded. If you look at these other ones here, well, there's the upper right, there's a quarter for scale. These are all jagged, angular pieces, so this would be poorly rounded. The lower right picture, these are all round, smooth. This is well-rounded. And of course, that sand I showed you before, that's also well-rounded. We also talk about how sorted they are. And we again have a spectrum from poorly sorted to well-sorted. So look at those pictures from before. You have all these different clasts, but if you measured them all, and again we do that, they're all pretty close to the same size. So this is well sorted. This is like if I gave a test and the average was 75 and everybody got either the range of grades was from 74 to 77. Boom. Compare that to rock B or this bigger picture over here. Here I could also say that the average size is 1 millimeter, or the average grade in that class was 75, but the grades ranged from a low of 22 to a high of 98. You see the difference there? So the average can be one thing, but the spread of the data. So in this one here, we've got sands, and then here these silts and clays, that's just different terms for smaller and smaller particles. The rock on the extreme right, that is poorly sorted, but it is reasonably well-rounded. The rock in the middle, rock B, is poorly sorted, but it's poorly rounded as well. And then the rock over here in rock A, well, that's well-rounded and well-sorted. We talk about it in terms of maturity. So mature rocks are well-sorted, well-rounded, mostly small, and then just a separate thing, they're mostly the mineral we call quartz. That indicates that these have undergone huge amounts of transport or what we call reworking. So if you memorize the mature side of things here, then the immature side is the exact opposite. Just a picture over here, two streams in two different places. So the stream on the left side, this mountainous stream, you can barely see a little water flowing in it. It's coming down. You see lots of big boulders and smaller, medium-sized ones and littler ones. And if you went into the stream, there'd be sand. This is poorly sorted. If you look at the edges, there's lots of sharp, angular bits, poorly rounded. Look at the stream on the right side of the diagram. There's the water is the blue flowing through here, and you see the brown sandbars. And if you went up there, it's all sand. Everything is between 1/16 of a millimeter to 2 millimeter. It's mostly quartz. This is well-rounded, well-sorted. So The left side is immature, the right side is mature. And the little cartoon at the bottom just shows sort of sediments as they go from mountains down to the ocean. They go from immature rocks to mature rocks. So we say that sedimentary environments change in that way, which takes us to this last slide for this note set. This is the famous, I call it the address slide. These are the sedimentary environments, or the environments of deposition, or the EOD, I'll use all those terms interchangeably, of all the different places where sediments can be deposited. And in those previous slides, in this note set, we were looking at what we're calling here the stream environment. And near the mountains, these clasts, these sediments are immature. And as they go down these streams, mile after mile, year after year, 10,000s of years, millions of years, whatever, they get more mature. And so if I find an ancient rock, a rock can be 500 million years old. But if I look at it and I can tell this came from a stream and it's relatively mature, I can say, well, I'm near this part of the stream versus that one. So this is your first example of how we use rocks and the present to tell about ancient environments.